Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe.
Level 108, use integration to determine the product of inertia Ixy and I bar xy for the half parabolic segment shown. So here is the given figure. So for our solution, let's consider horizontal strip. The length of the strip is x. Distance of the strip from the x-axis is y. And the thickness is dy as shown. The centroid of this elemental strip is at x over 2 comma y. So this is x over 2. Remember, Ixy is integral of xy differential area, where differential area is x dy, and the variable of integration is y. So limits would be 0 to h, where x in the formula Ixy differential area is the x coordinate of the centroid, which is x over 2, and y is the y coordinate of the centroid of the element, which is just y. So Ixy equals integral of xy dA, where x is x over 2 and y is just y, differential area is x dy. So Ixy equals integral of quantity x over 2 times y times x dy. Simplifying, Ixy equals 1 half integral of x squared y dy. So we must express x in terms of y. Since the equation of this parabola is given, then x squared, if we expand this, x squared over b squared. So x squared is b squared y over h. So Ixy equals 1 half integral of quantity b squared y over h from 0 to h of y dy. So Ixy therefore is b squared over 2h, and integral of y squared dy is y cubed over 3 from 0 to h. So therefore Ixy is equal to b squared over 2h times h cubed over 3 minus 0. So therefore it is b squared h squared over 6. Ixy equals b squared h squared over 6. Now for the product of inertia with respect to the centroidal axis, we must know the location of the parabola by experience from distributed forces on first moment of areas, location of centroids. So you just look for this problem, parabola, vertex here, open upward. So this distance is 3/8 of b. So the centroid is 3/8 of b from the y-axis, and it is 3/5 of h from the x-axis. So you must know this location, and the derivation of this is you just look for this figure, centroid of this figure in my playlist under this uh, subject statics. There are so many videos there, so you just look for that. Or you're required to locate the centroid or memorize the location of that centroid. So from Ixy equals I bar xy plus area barred x barred y, parallel axis theorem or transfer formula for product of inertia. So substitute b squared h squared over 6. Area of parabola is 2/3 base times height. Barred x is 3/8 of b, and barred y is 3/5 of h. So b squared h squared over 6 equals I barred xy plus 2/3 of base times height times quantity 3/8 of b times quantity 3/5 of h. Cancel 3. This is 4. So 3 over 20. 1/6 minus 3 over 20. bh square. So I bar xy can now be computed. It is b square h square over 60. So that's it. Level 109, determine the product of inertia of each of the four areas about the xy axis. So these are the four areas. Take note that these are rectangles, so moment of inertia with respect to the centroid would be zero. And it only has area barred x barred y. So parallel axis theorem for product of inertia, Ixy equals I barred xy plus area barred x barred y, where I barred xy is equal to 0. Then for the first rectangle A, Ixy equals 0 plus 60 times 30, barred x is 50, barred y is positive 40. So Ixy equals 3.6 times 10 to the 6 millimeters to the fourth. For this orientation of rectangle 2, Ixy equals 0 plus 30 times 60, barred x is negative 50, barred y positive 40. So Ixy equals negative 3.6 times 10 to the 6 mm to the fourth. For this orientation, Ixy equals, with respect to the centroidal axis 0, plus area 60 times 30, barred x is negative 50, barred y is negative 40, below this point. So Ixy equals 3.6 times 10 to the 6 mm to the fourth. And lastly, we expect that this is again negative of 3.6 because these two have equal moment of inertia. So if this is negative 3.6 times 10 to the 6, we expect that this is also negative 3.6 times 10 to the 6. So Ixy for part D is 30 times 0 plus 30 times 60. Barred x is 50, barred y is negative 40. So that's why Ixy is negative 3.6 times 10 to the 6 mm to the fourth. Level 110, determine the product of inertia of the parabolic area with respect to the x and y axis. Determine the product of inertia Ixy of the right half of the parabolic area bounded by the lines y equals 2 inches and x equals 0. So for the first part, considering the whole figure, and for the second part, considering only the right half, this one. And we already have derived the formula for Ixy of this parabola that is open upward from level 108, the first problem in this video. And it was b square h square over 6. So let's consider the first part for our solution. Since the y-axis is an axis of symmetry, remember the principal product of inertia of an area with at least one axis of symmetry is 0. But even so, we will show that it is 0. So Ixy equals I barred xy plus area barred x barred y. So assuming it is not 0 yet, so let's compute for I barred xy. Ixy is, with respect to the centroid, 0. By the way, Ixy is with respect to the centroid 0 because it has an axis of symmetry. Area of parabola is 2/3 base times height, 2/3 of 2 inches by 2 inches also. Barred x is, if you can, barred x, the centroid lies here, so barred x is 0. And barred y, even if you forget barred y, 3/5 of 2 inches, that's barred y. Because of barred x, which is 0, everything would be 0. So Ixy equals 0 plus 2/3 of 2 times 2 times 0 barred x, barred y is 3/5 of 2. So that's why Ixy is 0 for that parabola, because it has an axis of symmetry. Considering only the right half, the formula for Ixy is b square h square over 6 from level 108, the first problem discussed in this video. So where b is 1, h is 2. So Ixy equals 1 square times 2 square over 6. That's 4 over 6, or 2/3. So Ixy equals 2/3 inches to the fourth. Level 111, determined by direct integration the product of inertia of the given area with respect to the x and y axis. Also derive the formula for Ixy and I bar xy for the quarter ellipse. So here is the given figure for our solution. Let's consider vertical strip. So if this is treated as an ellipse, this semi major axis is denoted by A, and this semi-minor axis is denoted by B. So A is 2A actually, and B is A actually in this problem. So considering vertical strip, this is the equation of the ellipse x squared over a squared plus y squared over b squared equals 1. So again, A is 2A here, and B is A. Then Ixy, considering vertical strip, that's why the distance of every element of the strip from the y-axis is x. The thickness is dx, so the variable of integration is x. So limits would be 0 to a for this problem. Then the location of the centroid is here. So in the formula Ixy equals integral of xy dA, x is the x coordinate of the centroid of the element, so it is just x, while y is the y coordinate of the centroid of the element. In this case, because this is a rectangular strip, the height is y, so its centroid is y coordinate of centroid is y over 2. So that's y over 2. Ixy is integral of x y dA, where x is the x coordinate of the centroid of the element, which is just x, y is y over 2 in this case. dA is height times thickness, so y dx. Limits from 0 to a. So x, y over 2, y dx. Ixy therefore is 1/2 integral of x, y square. From this equation is b square quantity 1 minus x square over a square from here. If you derive y square, 1 minus b square times quantity 1 minus x square over a square. So simplifying, Ixy equals b square over 2 integral from 0 to a, then quantity x minus x cubed over a square after we distribute x. So Ixy equals b square over 2 quantity x square over 2 minus x to the fourth over 4a square from 0 to a. So Ixy is b square over 2 quantity a square over 2 minus a to the fourth over 4a square. Lower limit is 0, so minus 0. Everything is 0. So these are like terms. 1/2 minus 1/4 is 1/4 a square times b square over 2. So therefore Ixy is a square b square over 8. This is the formula for Ixy of an ellipse. Now, since a is 2a, we replace 2a for this problem, and b is a. So Ixy equals quantity 2a square times a square over 8. For this problem, the answer for Ixy is a square a to the fourth over 2. Now, with respect to the centroid of an ellipse, remember the location of the centroid, this is the equation in general, is 4/3 of a, 4/3 pi over a, or 4 pi over 3a, this one. So Ixy is a square b square over 8 in general. So that is 4a over 3 pi, while this distance is 4b over 3 pi. So that's barred x, this is barred y. By transfer formula, Ixy equals I barred xy plus area barred x barred y. Area of this ellipse is pi ab over 4. So a square b square over 8 equals I bar xy plus pi ab over 4 quantity 4a over 3 pi times quantity 4b over 3 pi. So cancel pi, cancel 4. So this is 4 a square b square over over 9 pi. Over 9 pi. So I bar xy equals 1 over 8 minus 4 over 9 pi of a square b square, or in decimal approximately I bar xy equals negative 0.016471 a square b square. So this is for an ellipse.